Okay, so now comes the time when you have a line and you get to write the equation for it. I had some comments on having help writing an equation. I don't want to take away your ability and your practice in writing equations, and so I'm going to write an equation for this line here. And so this is data that we collected in the graph. However, it's not what we're specifically interested in this problem. So don't be copying anything that I didn't do in this video into your equation because it doesn't apply. You're looking at kinetic energy versus velocity squared. I'm looking at force versus spring displacement. And so, actually, you know what would be better? I wonder if we could do force versus velocity. We'll go to 0.5. There we go. This is a different graph. So I'm looking at the force that I'm pushing in and the velocity. So then I can run a linear fit through this. I can go line like so. And so it's pretty linear, 0.99, that's pretty good. And so if I were to write the equation for this, this is what I would write. Let me see if I can do this. I'm just going to tell you. I would say force, because it's in y is equal to mx plus b form. So I would say force, because that's the variable on the y-axis. Force is equal to my slope, 21.31. And because it's a number, it has to have a unit with it. And so in my program, it automatically generates the units for me. I don't think it does that in graphical, but here's how you would do it. The reason I know it's newtons over meters over seconds is because it rises 21.31 newtons for every 1 meter per second. Now, you will be simplifying this, but I'm going to let you guys try to figure that out. But that would be the units of the slope. So far I've got force is equal to 21.31 newtons per meter per second. And then you got to multiply that by the x variable, which is the velocity. So I say force is equal to 21.31 newtons over meters over seconds times velocity plus my y-intercept. And my y-intercept should have units of newtons because it's a y variable.